Here we have another example of a truss, as the one shown here. Has 15, 15, 15, 15 feet and 15 and 5. Again, we need to calculate the reactions first, and then after that we calculate the forces in each and every element. So again, we'll use the software to do so and compare it with the results that were manually calculated. So again, we start by clicking on the software, which is MD Solids, and then we click on trusses. But we need first of all to decide what the grid size will be. So looking at 15, 15, 15, so if I would say in the grid, the scale, I will have two each 5 feet is equal to 2 grid units. If I say so, then I will need 6 units for each 15. 6, 6, 6, 6. The total is 24 units, so I need a 24 units of the grid on this direction, and this direction I will need 6 plus 2, 8. So for 24 I will go for 30 units of a grid by 30. So we go to, when you go to new truss, we'll make these equal to 30 for x, and say 32 and 32 for x and y, just to have more room. 30, 30. Now we have the grid here, so we'll use size of this one. So we'll have, again, it's on create and members, so we'll do start from here. We have 2 plus 2 plus 2. This is the first 15 feet, and 2, 3, 4, 5, 6. The second 15, and 1, 2, 3, 4, 5, 6. Third 15, 1, 2, 3, 4, 5, 6. This is the 4, 15. And then we have, in this direction is 15 plus 5, so we have 6 units plus 2, so it is equal to 8 units in the middle. So we go 1, 2, 3, 4, 5, 6, 7, 8. And this is 15 df, so it will be 6 units. 1, 2, 3, 4, 5, 6. And same thing goes for HB, is 6 units. So it's 1, 2, 3, 4, 5, 6. Now I'll just connect AB. This is A and this is B, and B and C, C and D, D and E, and they have G and D. This is D, and this is G, and this is G and B. So we got the truss. Now we go to the supports. Click on support. It is on create already. So for support, again, we say we click on this hinge, hold your mouse and drag it down and let go. So it becomes a roller. And same thing for hinge. Click, hold down, drag down, let go, and then click, hold, drag left and let go, becomes hinge. So we got the support also created for us. Now we'll go to loads. So click on loads, and it is on create again. So we have 15 at point B, so click on the joint and hold your mouse, and you can drag any direction you want to, because it is downwards. So that when it is downward, let go, you'll get this window and put the value, which is 10 kips, and click on enter load. So it did create the 10 for us. Now we have 20 at point G, so click on this joint, hold your mouse and drag down, let go, and input 20 here, and click enter load. These are all the loads we have. So now again we click on compute, and we get the results. So now let's compare these results with the results that were manually calculated. So we start here at AY is equal to 17.5, 17.5, and and uh, and this is EY is equal to 12.5, which is H, this one, because E is this one, so these are not matching. This is E and this is H, so it's meant to be. And for the horizontal, there is no horizontal because there is no horizontal force. So now if you compare the values here at this joint AC, A, now again the differences in the letters of the joint. So the AC here is the inclined one, which is 24.75, which is AB here, and equal to 24.75. And for AB is AH here, so AB here is 17.5, and here is also 17.5, this tension, and here is tension. So if you continue, compare, and for this joint B, this element, which is AB, is equal to 17.5, and HG, which is BD, is equal to tension 17.5 here. And for this joint, it is 24, and this value, which is BC, which is CE in the software. So for CE, so BC, which is our CE, so the value of BC is equal to 19.78, and it is says compression, so it is compression. And for the value of GB, GB is this value. CD is 1.77, it is 1.79, very close, so we're okay. And for joint C, which is this one, to joint A, and again this is 19, same, and this is 19, same, so CD should be 19, which is 19.75 compression, and CG, which is ED, 12.5, so CG is equal to 12.5 tension, and continue the same way. So just a comparison for the values that we calculated.